All right, this is a review of some of the concepts from Chapter 7 of my book, which is on hosting AI system components, and then also there's a supplement on tool calls. So I'm just going to go through this. Again, remind my students that this video is not a substitute for studying the chapter and the terms highlighted in the chapter using AI and other means to study. So, all right, well, let's see what we have here. There we go. It's working now. Hosting. So what is hosting? Well, it's where we store the data. It's where we store things and where we run them. So we can talk about both dimensions of hosting, storing and running things. We host far and near. So far is the cloud. And here we have a picture that kind of depicts a cloud. And I think it's an interesting picture here. The idea of the cloud, I don't know if it's kind of centralized a little bit, but we have the cloud there, a WAN, a wide area network. We have what's called the edge. The edge is kind of near the user. So you have the edge devices like, cell phones and smart glasses and watches or whatever like that. All kinds of edge devices. So that's the far is the cloud. And we think of near being the edge, near the users. So here's all the users over here using their different devices. So the question is, where should you run your AI system components? One option is to run things locally. So here I have a picture of a country bumpkin, aka hillbilly, who is using Microsoft Office up in the backwoods where he doesn't have internet connection. Actually, in these days with Skynet, is that what it is? The Musk company, Skylink. No, Skylink. With Skylink, you can have internet pretty much anywhere. So running things locally, you run it and load it on your own computer, or in other words, on the edge. Example of this is Microsoft Office 2016, which I loved. I thought that was a great version of Microsoft Office. And it ran, you loaded it onto the computer or downloaded it. You did not need the internet for it. There's no latency. Another example that I give is a self-driving car. Self-driving cars, you don't want latency if it's having to respond to traffic conditions or to obstacles in the road or whatever. So you'd want to run those AI models locally. Alternatively, you can run things in the cloud. That's where most of this is happening these days. So it's on some server farm somewhere. So a server farm, it's like a big data center that has racks and racks of computing equipment and storage and stuff like that. They call this pooled compute. It's pooled because we're sharing the compute across a lot of different users. Google Docs is a great example of this. I love Google Docs. You store it on their servers. Lots of people can access it. Also, Google Docs runs in the browser, which is a thin client, meaning you don't really have to install anything. It's not really a lot of code there. Mostly a little bit of JavaScript might be running in the browser, but otherwise it's doing a lot of the heavy lifting in the background. That we'll talk about in a bit. It's not on the servers. Software as a service, someone else is running the app, so that's very common as well. So much of what we see today is software running as a service. Although I watched a video recently saying software as a service may be coming to an end here. I don't think that's true, but it's a good way to deliver things from the cloud. Client-server architecture was also discussed in this chapter. So here we have some clients. The client is basically code that actually accesses other sources of code. So you have computers and cell phones and things like that. They have clients. They're the kind of the recipients of the data. And then the server, which is often in the cloud, doesn't have to be in the cloud, but that's the one that actually provides the data. And we might connect over the internet. So the client makes a request, runs the front end. So front end software is like user interface. The server provides responses. That's the back end software. So it could be things like managing the database or doing some types of calculations or whatever. There are different types of servers out there. So I have a little analogy for this, which I think is kind of fun. I got this from some website, and I'll have to show you. I think I have the link to where the website is, but it's like hosting a pool party. So imagine you want to have a pool party and invite your friends. It's So here's somebody thinking of having a pool party here. We host this. Now, one alternative that I'm not going to talk about because it is not necessarily the best is to have your own swimming pool. I consider myself fortunate to not have my own swimming pool because that is a pain in the neck to have to deal with. If you have your own swimming pool, you got to do everything yourself. You got to do all the chemicals yourself. You got to manage the thing yourself. You got to get your cleaning whatever device or whatever. It's just I don't think that's a good idea. I mean, some people like it. Some people like having their own swimming pool. But if I want to go swimming, I'd rather just go to some other swimming pool somewhere else. So what we're going to do is look at cloud hosting. So that's like rent a pool. We're going to use somebody else's pool. So it's going to be a pooling party. So get it? It's like wordplay there. It's pooled resources, shared resources. Okay. Not extremely funny, but still kind of wordplay there. The pool is the server. Inside of the pool, we have all kinds of toys. That's the software elements, different microservices or other kinds of things we have available. The guests are the users. They're the users that want to come and play with the toys. You use the software elements on the server. Okay, so we have different types of hosting. So I'm going to look at 4 types. We have shared hosting, managed shared hosting, VPS, virtual private server hosting, and dedicated server hosting. And here's the analogy here. So I got this from the HostGator's website. So it has these 4 types. I'll take you through each of these 4 types here. First, shared hosting. So that's the idea that we go to a public pool. You have a pass. You just go to the city pool or whatever. You have a pass to get in. You can bring some toys. You can bring your ball, or you can bring some of those foam, what do they call those things? Those foam rod things that you bonk everybody on the head with. I don't know what those things are called. So the toys are like scripts or plugins, things that you use. You can bring your friends to come and use this. You cannot change the water. So the water in this analogy represents the operating system. Okay, so if you're doing shared hosting, if you go into the pool and you say, hey, I don't want to do this kind of water here. I want to have lemon lime water to swim in or something like that. They're not going to let you change the water. Many people can use the same pool, but there are some problems with that. For example, if you have big parties, it might overwhelm the public pool, especially if there's other people using it as well. That could be a problem. What if someone pees in the pool? So in the analogy, the pee in the pool is like getting some kind of software virus or something like that. If that happens, if somebody pees in the pool, everyone suffers. So if you get a virus on shared hosting, it can be bad news. However, it is very inexpensive. It's just paying for your pass. It's pretty simple. All right, that's the low-cost alternative, okay? Managed shared hosting is a little bit better. So with managed shared hosting, it's similar to shared hosting. You're using the public pool. The difference is they provide the toys. So you actually sign up for the birthday package at the public pool, and they will provide some toys for you, and they will keep their toys in good repair. They will manage those things. However, still you have the problem someone pees in the pool, everyone suffers. But the host is there. If you pay for the special occasion package at the swimming pool, you might get some special assistance. It might cost a little bit more than shared hosting. All right, number 3. So that's cheap. It's also relatively inexpensive, but you get some help there. I'm going to skip to number 4 and then come back to number 3 for reasons that we'll see. So number 4 is dedicated self-hosting. So in this situation, I guess you could do that on your own premises, or prem as they call it. So you have your own pool. You're going to do your own hosting. You do whatever you want. If you have your own server, and I do this quite a bit, I have my own servers, you do whatever you want with it. You can change the water. You pick whatever operating system you want. You add any toys you want to this. You know, I put any plugins or software or utilities or anything I want. Security, chlorine or bromine, put whatever you want in there. High security, low security, although I found that my servers, I am told what security I need to do by the university, which is fine. I'm happy to comply with that. But generally, I have control over a bare metal server, meaning I'm actually running things on the hardware myself. But I have to do everything. Oh, if someone pees in the pool, I may need to drain the pool. It's been many, many years since I've had hack into one of my servers that was very successful. And so, but I did have at one point some problem where I had to kind of rebuild the server. It's probably been 20 years or more ago. But anyway, that's one of the challenges is you're responsible for this. You need maintenance know-how. So this is what I was talking about at the beginning is the idea of having your own pool is a lot of work. You have to have maintenance know-how. All right. Next to last but not least. So there you have maximum control. Number 3, the virtual private server or the virtual machine. This is super popular today. So what you have is a pool, but you have a private section of that pool. You don't need the whole pool. You have a walled off portion, so we'll actually wall it off so that if somebody else does something crazy in another portion of the pool, it doesn't affect you. No one else can pee in your pool. You can put whatever you want in the water or portions of many pools. So actually, when you have server farms, wow, you could actually have portions of a lot if you have scaling. We talked about that back in chapter 6, about scalability in Kubernetes and things like that. So that's an example. Containerization, Docker is great. Docker shares the same operating system, but I think if you use Kubernetes, you can use different operating systems for that. I mentioned this term hypervisor. What that is, it lets you have different operating systems on each virtual machine. But anyway, this is like Amazon Web Services or other things where you say, oh, I'd like to have a server in the cloud. They don't actually give you a server. What they do is give you a virtual server. So it's as though you have a server, and you may be sharing that physical piece of computer hardware with other users. That's okay, because your part is walled off. All right, safe, scalable, and often you pay as you go. So this is the most scalable alternative. A great alternative for things that need to scale up and scale down. And you pay as you go, and the prices actually are not too bad. As last I looked at them, to have Amazon Web Services, it's, pennies per gigabyte of transfer or storage or whatever. So it's pretty efficient, unless, of course, you're up to some big, massive type of service you're providing, software as a service. All right, so which is the best? That's just what I want to point out with most of these things. There are trade-offs here. So this slide kind of shows, you might want to pause for this to just soak this all in here. But there are trade-offs. Some are less expensive, some are more expensive, some give more control or less control, things like that. So it's not like there's one solution that's the best for everything. I actually have liked the dedicated server just because I like to fiddle and do things my way and have that control. Someday I may be weaned off of that and do virtual private servers or something like that. But anyway, each person might have their own preference for a particular project. All right, so I just added this new thing here, a cloud hosting options, a little case study here to kind of illustrate this. So I was looking at Canvas. So Canvas is what we currently use for maintaining the course content. And what happens is I create assignments and I have to edit them and put in bullet points and links to watching the video and things like that. And so the assignments are really kind of like a web page. That's what they wind up kind of being with, different types of fonts and headings and things like that. I was curious about this. I was curious about how Canvas has such a nice editor. I thought, wow, they've done a great job with this. I thought, no, I bet they got this from somebody else. So with a little investigation, I found out that if I hit the F8 button, or Alt F8 I mean, it opens this little keyboard shortcuts. And at the bottom it says you can find more shortcuts at Tiny MCE keyboard shortcuts. Whoa! Canvas as a company does not have its own editor. They actually are outsourcing this to another company, Tiny MCE, a company called Tiny something. Anyway, I went to tiny.cloud. So I went to their website, and it said you can add it to your app, the most trusted feature-rich WYSIWYG, which is like a, editor. What you see is what you get. Rich text editor. Okay? And so they have this little utility that you can add to your app. And I think for my apps, if I need to have, editing in it, wow, this is a great alternative. So I thought, well, how do you get this thing? It's kind of open source. So I looked at it and I saw, there's an aspect of this that's open source. So here's what I tried to find out, is how I would actually access this thing. So here, when I clicked on products, it said download TinyMCE for free. Oh, well, if it lets me download it for free, that makes me think maybe it really is open source. So I clicked on that link, and here's what I saw. They had two parts of this. It is self-hosted versus cloud-hosted. So you can pay them, and they will host it for you, or you can self-host it, or there are cloud hosting options. So self-hosting, you can run it on your own server. They have a free option with that. I thought that seemed kind of nice. And the one challenge with that is you'll notice the license is GPL2, the general public license. And the problem with that is that it's such that if you make it part of an application that's also that you've developed, the entire application becomes GPL, becomes open source. So for GPL eligible products, it would only work for products that can be GPL. So no, that's not the best. I wouldn't really want to do that. Although there is a way to get around that, is that you can, if you have a software as a service, reportedly, as long as you don't distribute any code at all, then you can keep your code proprietary. But if you distribute any code at all, you have to distribute it as GPL. Anyway, that's from way back in, what is it, chapter 4, we talked about that. Okay, so in self-hosting, it does say it requires manual security updates and server maintenance. That's you. You have to do that. You have to do your own security updates, maintain your own server. Okay, but you have full control over when and what's deployed. So that's what we were talking about earlier. Cloud hosting, on the other hand, what they say, this is what you pay them for. They say automated feature updates so you can scale fast, worry-free maintenance and security. Okay, that sounds pretty good. And they have the free tier there, so you see where it says free, and I'll let you know in love with inbuilt features. So I actually went to their link about what the free was. They have free, and then they have a commercial version that's not free. So here's what they showed here. They call it their cloud-hosted plans. They have the free one. The free plan, as you can see there on the left, it says they host and maintain it. You get 1,000 loads per month. That means 1,000 people can actually download this thing. It's about a 470 kilobyte file, JavaScript file. And they will serve that to your users. And after that, you got to pay $40 per 1,000 loads. So it's not free at that point, you know. So something to think about there. It's kind of free, but kind of not free. Low scale, this would be fantastic. But then up higher than that, they have the $500. So the freer alternative is to just host it myself, is to download the open source version, put it on my own server that I have myself. I can put it wherever I want. I can use it. It's this file, which it's going to take some bandwidth. You know, it's not a small file. It's almost a half a megabyte. It's still not too big. But I have to maintain it myself. You know, I probably could live with that. So I think for myself, I probably would take the freer alternative, which is to just host it myself. But again, you have these alternatives. Interestingly, I went into Canvas and I looked at the source of their Canvas editor code, and it appears that they're using Amazon Web Services CloudFront. So they're actually paying to have it hosted, which is a very relatively inexpensive alternative. Or you can pay these people tiny.cloud and they'll host it for you. I suspect in Amazon Web Services, they hosted it at a cheaper rate. In fact, even tiny.cloud probably is using Google Cloud or Amazon Web Services or something like that for their hosting. All right, last little section here. In the chapter, we talked about different placement of the pieces. What I want to point out with this final thing here is that there's not just one place to put things. That you can actually have an app that's spread over a lot of different places, you know, and that, you know, even one app can have lots of hosting options represented in it. So what and where do we have? So we have different components, things like the front end. So the front end runs in a browser, but you got to store it somewhere. It doesn't come in the browser. You got to load a page there. So the question is, where do you keep that? You have a coordination layer, so that could be like middleware and things like that, middleware. Connecting to other services like AI services and things like that. The large language models. Vector databases you might have, or other databases. Microservices. These are little focused utilities that will, you know, do very specific things like provide a weather report or, you know, I don't know, look up news feeds or something like that. So options are edge devices, on premises, you do the cloud, multiple cloud providers, sometimes people will do for redundancy and things like that. So let me take you through a few examples of some of these decisions. So one of these would be like ChatGPT. So the browser, it runs in a browser. Claude will run in a browser, or you can download the app. But I haven't seen a ChatGPT app yet. So it connects over the internet using hypertext transfer protocol. So it's just a common way it communicates with the ChatGPT server. And the ChatGPT server then has to connect to the large language model, which could be on a different machine, maybe in the same server farm. Okay, so we type in our commands. They go to some application server, probably Azure. That's Microsoft, since Azure at one point owned 49% of OpenAI or something like that. I don't know what it was, but anyway, they own a significant portion of OpenAI. Probably not anymore. But wherever that is, there's some server farm, and then there's also moderation servers where they do things like moderate the results and filter to make sure you don't have problems with it, toxicity or whatever. All right. Another one, Google Docs. Oh, love Google Docs. So there you have a thin client running in a browser, and you go to their servers, and they keep it there. One thing I discovered is in Google Docs, I was on an airplane once, and I discovered it would not do spell checking while I was on the airplane. I thought, oh, that's running in the cloud. Google Docs will let you do a lot of the editing and setting fonts and things like that in the server, but the cloud, you got to go to the cloud if you want to apparently do things like spell checking, and certainly things like some of their new AI features are all running in the cloud. Adobe Photoshop, if that's still around at the time you're watching this, it has a thick client. You got to install this thing on your local computer, and it's quite a large program. Something I don't like about Adobe products is their massive, thick clients. Very involved, very powerful, but very involved. And then if you want to access some features like their in-painting system using AI, it doesn't run on your local thick client in Photoshop. That would run somewhere in the cloud. It could run locally if you had the right model, but I haven't seen it ever do that. Poe, it's an AI builder. They go to the cloud service running somewhere in the cloud, and then you have LLMs. They don't have their own LLMs, so Poe is running there. So it might use any of some combination. It's kind of agnostic about this. GPT. It's funny that I listed 4.0 there. We're not using 4.0 anymore, but Gemini, Claude, that is Llama. Zapier, I talked about this in class, is you have Zapier, the browser goes to the Zapier website, and Zapier, what's really great about it is it'll connect to things like Gmail, it'll connect to different databases, it'll connect to different large language models, and so it's really great for connecting things. Finally, we have local hosting, which is what I like to do. You could have a computer. Well, actually, this is talking about learning the whole thing locally. You could even run the large language model running Llama or LM Studio, and then just connect within the computer to a server. You can actually run your server on the same computer as the client and running on the same computer. And so that's another alternative. Run things locally. We're really looking for smaller models to do that, and maybe even better hardware. You can run all your models locally. All right, here we go. Here's an example of some hardware. This is RTX. It's a NVIDIA 3080. Not super powerful, but still can run some large language models like Llama 3 8B. Or NPUs. There's other kinds of devices out there. I have one other slide here. I'm not exactly sure why, but it's about GPU clusters. You can actually buy these things. So it's a bunch of GPUs running in a server rack here. At the time I made this slide, which was probably 2 years ago now, a NVIDIA RTX 4000 was $600 to $1,400. An A100 was $8,000 to $10,000. Price of those will come down now, I'm sure, because they have better things out. Oh, there we go. An H100, even better. Okay, so this is their Grace Blackwell platform, I believe. So here's one that I saw online listed. It had 8 H100s, 2 terabytes of RAM, which is pretty good, but not extraordinary. It comes with some consulting, and here you can buy this thing on sale for $288,000 for a GPU cluster. I think the cost of these GPUs, they will come down, but still, currently they're pretty expensive, which is why we often outsource our hosting. All right, that's the end of the Chapter 7 stuff. I have a little bit more about tool calls and MCP that I can tack onto this here. So the idea of a tool call is that we have a AI system that may have a large language model that's part of it, and we want to access other data sources. And how do we access these other data sources? Well, we can do that through tool calls. Now, the unfortunate thing is that the people that are making this stuff up right now, like OpenAI and other companies, they keep changing the names of these things. Tool call, OpenAI just recently, in the last month or so, decided to call these things apps instead of tools. I don't know. I don't like that idea of calling them apps. The word app's already been used. The dictionary entry for app is full. Even tool calls is maybe not necessarily the best. But we'll talk about MCP, which is one of these ways that we can access tools. So we have, I like this diagram here. We have a user that types in a prompt that goes into some application. And the application could be like ChatGPT, or it could be some tool that does things like, grammar checking or whatever. And what happens is the app, it calls the AI model, and the model processes it. If the model is tool capable or function capable, as we used to call it, it will say, oh, I need some help with this. And what it does is it identifies what function it needs to call and sends that back to the application and says, hey, this is not the answer. This is the function identifier and the parameters. It's things like, the person asked me for who won the Atlanta Braves game last week. And I don't know that, but I'm going to go to a function that's going to look up Atlanta Braves scores or Major League Baseball scores or whatever. And then what happens is that function call in the application, it then echoes that thing out through an API to some service that goes and looks up scores and gets a response. And then that function takes that response and throws it back to the model and says, hey, here's your response, use that. This can actually happen multiple times. This diagram only shows it once, but it can happen multiple times for a particular prompt that you give the model, which is one of the reasons why sometimes these models seems like forever to be able to resolve things, because they keep doing function calls to get the data that they need. Finally, when the model's ready, it gives you the response, which can be formatted and given back to the user. So that's kind of the idea behind tool or function calling, is that we call other resources from our large language models so that those resources can be helpful to us. All right, before we had MCP. So MCP, I'm sorry, I should have listed what this is. Model Context Protocol. So it's getting context information. We talked about that before, like chapter 5, we talked about that a lot. So before we had the Model Context Protocol, every service, so at the top of this diagram we have a large language model, every service had its own unique API, application programming program interface. So there we have, that one on the left is Slack, Google Docs, GitHub, or whatever. They all have their own APIs. Holy schmoly! It's so hard to kind of keep these things keep track of these things. And even I've discovered, even in the last few years, that these companies will change their APIs and it breaks. My software stops working because they changed their API. And so, okay, well, that's the problem. So after MCP, we have now a unified API. So you have one API, which is MCP. And it's kind of standard, and you can use it to access all kinds of different services out there to get context for your inference. Hallelujah. Here's another diagram. Without MCP, every LLM has to figure out how to communicate with every different device. With MCP, you can have the LLMs all have the standard way they communicate with all types of information sources. All right, some elements of this. So I like this diagram here on the left. So here we have Claude Desktop. So Claude Desktop is like a Claude program that runs on your computer there. And then it wants to access GitHub. It wants to access Slack. I don't know why everybody puts GitHub and Slack in there. Maybe it's because the programmers that write these diagrams for these things, they're really big into GitHub and Slack and such. So, and here we have Google Maps. I don't know what Blue Sky is, but that's as well. So basically what happens is we have the MCP host. That would be the app, like Claude Desktop or whatever. Or maybe a scheduling app that wants to look up schedules for things, or a recipe app that wants to look up recipes from a database or whatever. Okay, so it's an app that needs the data. We have the MCP client. That's a component within the host that accesses MCP. It just basically says, hey, if you need to access MCP, this little part of the program, what we call a subroutine or function will actually do that for us. It communicates over the MCP protocol as shown in this diagram. So here we have some little arrows showing communicating through MCP. And usually MCP will use JSON, which we talked about in another chapter. Structured way of communicating, very commonly used for communication. And then the MCP server, these are the ones that actually serve up the data. They use their own APIs to access their specific data. So in the case of GitHub, there's a GitHub server that knows how to access GitHub data. And when it gets the message in saying, hey, we need to get something off of GitHub, it will then ping the database, and the database will return it. One problem with this diagram is the arrows should really be going both directions. It's showing kind of the initial call connections. But after it gets the data through the API, the GitHub server will pass it back through the MCP protocol back to the Claude desktop. And then it has the information it needs and all is well. I hope that makes sense. I kind of, like I said, I really like this diagram, but kind of representing how this works. There are a few different types of MCP servers, and this diagram kind of enumerates this. You have tools, resources, and prompts. So the client might need tools, query the resource. So a tool would be, it does something, you know. It might be something like, suppose it's a tool that does home automation, or some tool that, you know, I don't know, stores stuff in a database or whatever. It could be anything. Resources, it could be just data sources like an online data repository, information like knowing who won the Braves games or whatever like that. It could be resources. Prompts, they have these things called prompt templates, where you have a prompt and you know you want to accomplish certain things. Super complex prompts, that could be another one that's available. So that's kind of what we have is tools, resources, and prompts. Those goes into MCP. So that's just a little bit of MCP and tool call. Tool calls are super important. In the past year, and I'm recording this in, what are we in, February 2026. In the past year, tool calls have become in the front of what's happening with AI. Is that the original models were kind of stupid past the cutoff date. They didn't know anything. Now everything's using tool calls all the time. Lots of tool calls. And MCP is what makes it. I hope MCP lasts. If it doesn't, something will replace it. But it makes things standard enough that it's just manageable, that we can actually communicate with all types of different services, kind of plug and play. Well, that's all for Chapter 7 and 7a. And if I can endure, we'll see you on the next one. Again, students, this is not a substitute for studying the chapter, for studying the terms in the chapter, looking them up on AI, and preparing yourself.